So they're saying the conversion of sulfur dioxide to sulfur trioxide is a reversible reaction which can reach equilibrium. Give two features of an equilibrium. Do you remember what were the features we discussed about dynamic equilibrium?
Yes.
What are the features?
The rate of the forward
Yes.
is equal to the
Yes. Correct.
the rate of the backward reaction.
Correct. Rate of forward reaction is equal to the rate of backward reaction. Correct.
And the concentration of the
Mhm.
concentration remains constant.
Right. The concentration of the reactant and the product remains constant.
Yes.
Concentration of the reactant and the product remains constant. And I told you a third one as well. Well, here you don't need to write down three, but just for the sake of revision, the third one was the forward and the backward reaction occur at the same time. So those are actually three features.
Yes.
Okay. The next question is the conditions and the catalyst. That's not your topic. Now, complete table 3.1 to show the effect, if any, when the following changes are applied to the conversion of sulfur dioxide to sulfur trioxide. The forward reaction is exothermic. Only use the words increase, decrease, or no change. So let's take a look. They're saying we are decreasing the temperature. Okay. They have told us that if we decrease the temperature, the rate of reaction decreases. And you and I know that. We studied the topic of rate of reaction. In the topic of rate of reaction, we studied that temperature. So when temperature will decrease, molecules will have less energy, so there will be less collisions. So rate of reaction will decrease. They have written that.
Yes.
After that, they're saying what will be the effect on the concentration of sulfur trioxide at equilibrium. So what will be the effect on equilibrium? Now you have to
No
remember.
change.
Do you remember what hold on. Why no change?
Since the temperature
Okay.
is
Do you remember
yeah.
Do you remember when I made a table for you? I
Yes.
told you when temperature will decrease, what will happen, and when temperature will increase, what will happen. When temperature will decrease, the reaction will shift to the exothermic side. When I will decrease the temperature, the reaction will shift to the side that produces heat energy, the exothermic side. If I will increase the temperature, the reaction will shift to the side that is endothermic, the side that, that will absorb the heat energy. So the temperature comes back down. So they are telling us in this particular scenario, what have they told us? They have told us that the forward reaction is exothermic, right? That's what it says in the question. Forward reaction is exothermic. So if I'm increasing the temperature, should my reaction forward or backwards?
Miss, the forward reaction is the reactant or the product?
Forward reaction is the product. When you go to the
product.
forward reaction, forward reaction is this one when you are going this way towards the right side.
Okay. And the backward is the reactant side, right?
Yes. Backwards is when towards the reaction. So in this case, the forward reaction is the exothermic one, right? This is what you have to basically remember, these two lines.
Yes.
So when temperature will decrease, you go to the exothermic side. Okay. Which side is exothermic? Is the forward side exothermic or the backward side exothermic? The forward side is
The
exothermic.
forward.
So what will, yes. So our equilibrium will go forward. That's the right side. So equilibrium will shift to the right.
Right.
And when the equilibrium will shift to the right, what will happen to sulfur trioxide? Will I get more sulfur trioxide or will I get less sulfur trioxide? If you remember, I told you, whenever the equilibrium goes to the right side, whenever the equilibrium goes to the product side, what happens? The product increases. We get more product. So what will happen?
So it's gonna increase.
Yes, sulfur trioxide is going to increase. So your answer over here is going to be that it is going to increase. Okay. Next one, they're saying, what is the effect of pressure? Now, we have to talk about pressure on two things, not just the rate of reaction, not just the equilibrium, but also on the rate of reaction. So when we did the topic of rate of reaction, right, I had
Yeah.
told you the different factors that affect the speed of a reaction. So what do you remember about pressure? Does pressure, if I increase the pressure, what will happen to the rate of reaction?
There will be more reacting products.
Right. So is the reaction going to be faster? Is it going to be slower? What's going to happen?
It's gonna be faster.
Yes, it's going to be faster. Correct. The rate of reaction is going to increase because I'm increasing the pressure, right? When I increase the pressure, the molecules are going to get really close to each other because I'm compressing the gas. I'm pressurizing the gas. I'm pushing all the gas together. So all the molecules will gain more energy. And when they will gain more, so the molecules will actually come close to each other. When they will come close to each other, so of course there will be more collisions happening, so the rate of reaction will increase. Now, we have to talk about what will happen to the equilibrium position. To discuss what will happen to the equilibrium position, we have to remember, again, just like with temperature, I told you, you have to remember what happens when the temperature decreases and when it increases. So what we had studied for pressure was that when I will increase the pressure, the reaction will go to the side with less number.
Number of gas molecules.
Yes, correct. And if I decrease the pressure, the reaction goes to the side with
With
more
the larger
number.
number of molecules.
Exactly. So in this particular situation, take a look at the right side and the left side. Which side has more number of molecules? The right side has
The left
more
side
number of
has
molecules
more.
or the left side? Take a look. This is the left
Uh,
side. Left
yes,
side has 3, 2 from
yes.
SO2 and 1 from oxygen, correct? And what about the right side? The right side has
It has to.
2.
So the more is the left side.
Right. The more is the left side. So over here, they're increasing the pressure. So when pressure increases, less number of molecules. We go to the side with less number of molecules. So the
So
right
at the
side has
right
this. Yes. So equilibrium will shift to
to the
the
right.
right. And whenever the equilibrium goes to the right, what happens to the product? The product increases. So I will get more product. That means I will get more sulfur trioxide. So I will over here write down my answer as increase. My sulfur trioxide, the concentration of sulfur trioxide will increase. Finally, they are asking a catalyst. No catalyst. If I don't put any catalyst, the rate of reaction will decrease. And you and I know that a catalyst makes a reaction faster. So if there is no catalyst, then the reaction will, of course, not be fast. It will be a slow reaction. But what about equilibrium? Do you remember? I had told you once one line about the effect of catalyst on equilibrium. Do you remember what it was?
Mm.
A
For the
catalyst,
catalyst, it doesn't affect
yes,
the rate. The rate of
yes. It
it
doesn't
doesn't
affect the
affect it. So
equilibrium. Yeah, not the rate. The rate it will
yes,
affect, but the
but it does.
equilibrium it doesn't affect.
But does affect the speed of the equilibrium.
Yes, it does. Exactly. It affects the speed of both the forward reaction and the backward reaction. Since it's
Yes.
affecting both the forward one and the backward one, so equilibrium doesn't change. So there will be no change or there will be no effect, right? So that's
Yeah.
our table that we complete. Okay. Now they're saying, okay, this is related to rate of reaction. So rate of reaction is done, right? That is not coming in your test. Only the topic of your equilibrium and dynamic equilibrium and all of this is coming.
So it doesn't have to. It's not related to the previous. It's only related to
To
the
the
one.
dynamic, right? Okay.
Yeah.
Okay. All right. Okay. Hold on. Just give me a second. Let's open up another question.
Miss, I have a question. Do we have to memorize about the effect of pressure and temperature and the concentration and the catalyst?
Yes. Yes. You have to remember this. You have to remember whether the so for pressure, just remember
Yes.
it like this. If pressure increases, we go, so it's opposite, okay? If I'm increasing the pressure, I will go to the side with less molecules. So I'm increasing the pressure, but I'm going to the side that's lesser. So I'm going opposite to it. So if I increase the pressure, I go to the side with less number of molecules. If I decrease the pressure, I will do the opposite. What's the opposite of decrease? Increase, right? So I go
Increase,
to
yeah.
the side. So I go to the side with
Larger.
greater number of molecules, right? The
Yeah.
opposite of. So that's how you can remember it. That's for pressure. For
So like
temperature, mhm,
increasing the pressure, the pressure wants to reduce it. Like,
yes, exactly,
and
exactly.
then by decreasing the pressure, they want to increase the pressure, right? So it's
Yes,
like,
exactly. Exactly. So what's happening is that when I'm decreasing the pressure, what is happening that my pressure wants to come back to normal. The only way my pressure can come back up because I have decreased it. So the only way the pressure can come back up is to go to the side with more molecules. So more molecules mean more collisions, right? And
yes.
on the other hand, if I increase my pressure, so now my pressure is too much. Now we have to bring it back down. So how can I bring it back down? Less molecules, so less
Yes.
collision.
Yes.
And then for temperature, again, for temperature, you're going to take a look at your, you are going to go ahead and consider, again, if I am increasing the temperature, the reaction is going to go to the endothermic side. Again, it's the opposite, okay?
Okay.
Endothermic is when I'm absorbing heat, okay? When I'm taking in all the heat. So what's happening is that I have increased the heat. When I have increased the temperature, when I have increased the heat, what's going to happen? I need to bring the temperature back to normal. How can I do that? I can do that by shifting the reaction to the endothermic side because in endothermic, you're
Yes.
absorbing all the heat energy, you're taking all the heat energy. So all that heat energy that I've given, all the temperature I have raised, all that energy will be absorbed back and the temperature comes down.
Are
Similarly, if
are
I
they gonna
decrease
ask
the
us like are they gonna ask us in like the theory part, or are they gonna ask us like
no,
why
the
did the
why,
temperature
not really. You don't get a lot of questions on why. The why they will not ask you. They will ask you questions like this. So they will give you the reaction and then they will ask you that we are increasing the temperature, we're increasing the pressure, what will happen? Right? That's what they're going to ask you. The why
Oh,
is just for you to understand why it is happening. They will
yeah.
ask you, tell us what will happen. So you don't have to give the reason why it is happening. You just have to remember what will happen with temperature, pressure, and catalyst. That's it. So see, this is another question. This is the question about Haber process, which inshallah, again, that's another topic. They're saying the equation for the Haber process is shown. The reaction is reversible. The forward reaction is exothermic. And see, I told you in an exothermic reaction, they would write down delta H and they would give you a negative value. So
Yes.
whenever it's written delta H with a minus sign, that means the forward reaction is exothermic. This value is always for the forward reaction. So we have over here, what do we know? We know that our forward reaction is the exothermic one. So remember,
Yes.
the forward reaction and the backward reaction are opposite. So if the forward reaction is exothermic, automatically the backward reaction will become endothermic. Okay. Now,
Yes.
we have to go ahead and take a look at it. They're asking, we have to again complete the table, just like we did it before. So let's go ahead and complete the table. To complete the table, okay, now let's revise. Let's first talk about temperature. If I increase the temperature, my reaction will shift to what side? Endothermic side or exothermic side?
Endothermic.
If I increase, yes, correct. And if I decrease the temperature, where will the temperature shift? Where will the
Exothermic.
correct?
And while we increase the temperature, the reaction absorbs heat.
Yes, exactly. And when we decrease the temperature, the reaction
It
releases heat.
releases heat. Yes.
Correct. So over here, they're saying we are increasing the temperature. If I am increasing the temperature, where is the reaction going to go? The endothermic or the exothermic? If I increase the temperature. So in the question, they are increasing temperature. In the question, they are increasing temperature. So if I increase the temperature, where is it going to go? Endothermic or exothermic?
Endothermic.
It will go endothermic. Completely correct. Good job. So now forward reaction, they told you the forward reaction is exothermic. So that means
Endothermic.
the backward reaction must be endothermic. So
Endothermic.
where is the reaction going to? Is the reaction going to go forward or is the reaction going to go backwards?
Backward.
So if I increase the temperature, will it go forward or backward? Backward, exactly. My equilibrium will go backwards because, like you said, we have increased the temperature. When we increase the temperature reaction goes to the endothermic side. Which side is endothermic? Backward reaction. So the reaction goes backwards. It goes to the left, basically, right?
Yes.
Whenever we say backwards, we mean the left side. So, and I
Yes.
told you, if you remember, I told you that if the reaction goes to the right, it means more product. If the
Yes.
reaction goes to the
Less product.
left, that means less product. So what will
Yes.
happen to the product? What will happen to the product? What will happen to our product? We will get less ammonia. So our answer over here will be decrease.
Decrease.
Right? Making sense?
Yes. So basically,
Okay.
since
Mm-hmm.
we increase the temperature, it's gonna go to the backward to the left.
Yes. Yes.
So if we go to the left side, that means less product. But
Yes.
if they ask if the temperature increase,
Mm-hmm.
no, the opposite. If they ask you temperature decrease, it's gonna go to
Mm-hmm.
the right side, which means more product. So
Yes.
it's gonna be
Exactly.
increased, right? If it's
Yes.
the temperature
Yes.
decrease.
Yes. If I decrease the temperature, the reaction will go to the exothermic side. That's the forward side. So the forward side is the right side. So yes, product will increase. Exactly. Completely correct. Okay.
Okay.
Next, they're saying we have, um, next, they're basically saying that we are dealing with pressure, but they're decreasing the pressure. So first thing is first. First thing is they're not asking you about equilibrium. First thing, they're asking you about the rate of reaction, the speed of the reaction. So what do you think? Is the speed of the reaction going to increase or decrease? If I decrease the pressure, if the pressure is less, will my reaction be faster or will it be slower?
It's gonna be faster.
If I decrease the pressure, if I make less pressure,
Mm,
remember this. When the pressure is high, the
yes.
molecules are close to each other, right? Because I'm putting a lot of pressure. I'm pushing all the molecules together. Molecules are close to each other. More collisions, rate of reaction will increase. If the pressure is less, then I'm not pushing the molecules anymore. So the molecules will not really bump into each other. They won't collide as much. So the rate of reaction will decrease, right? Rate of reaction will
Yes.
decrease. Speed of the reaction will decrease. Speed will become
Why
slower.
though? Why did it decrease?
Because I have decreased the pressure. So the molecule, so, okay, look, when I increase the pressure, what am I doing? I'm pushing all the molecules together, right? When I push all the molecules together, all the molecules come together. So what happens? That they're close to each other. So there will be more collisions. And when there are more collisions, what happens? The rate of reaction increases, right? That's what we had studied in the previous
Yes.
chapter, that when there are more collisions, the rate of reaction increases. So when I increase the pressure, I am pushing all the molecules together. When I push all those molecules together, so they will collide into each other even more. They will bump into each other even more. So rate of reaction will increase. When I do the opposite, when I decrease the pressure, now the molecules, I'm not pushing them anymore. I'm not pushing the molecules close together anymore. So now the molecules are far away from each other. Since they're far away from each other, so they won't collide as much. So less collisions means that rate of reaction will decrease. Making sense now? Why is it decreasing?
Yes. Kind
Okay.
of. Yeah.
Okay. All right. Next, they're saying effect on the concentration of ammonia. Now, this is the topic that you're doing right now. What did we study about? What did we study about our topic of equilibrium? How does pressure affect? When I increase the pressure, where does it?
Increase the pressure.
When I
It
increase the pressure, where will it shift? Remember,
it will
yeah,
it will
yeah, go
it
on.
will go it will go to the side that has the less molecules.
Yes, correct,
Less number
completely
of
correct, completely correct. And when I will decrease the pressure, where will it go?
it goes it goes to the side with more molecules.
Correct. So over here, we have the right side and the left side. How many molecules on the right side? This is the right
Right
side.
side right side is 2, and in the left side is 4.
Yes. Yes, completely correct. So my right side is 2 and my left side is 4. So over here, I am doing what? The question is saying that we are decreasing the temperature. So if I'm decreasing the temperature, it has to go to more molecules. Where do you have more molecules? Left or right?
In the left side, so it's gonna
Left. Go to the left.
yes,
So what will happen to the product? Will I get more product or less product?
more product.
Okay, remember this. Right side is more product, left side is less product. Okay,
Oh
left
yes,
side,
less product. Less
yes,
product.
is less product. So that means that
That means it's
my
gonna
ammonia, NH3 ammonia, I will get less ammonia.
so it's gonna decrease.
Yes, exactly. So I write down right over here, decrease. And finally, we have no catalyst. If I have no catalyst, do you think that will affect the equilibrium?
No, there's no effect.
No change. Correct. And that's it. This is our table that is complete. For pressure, so remember this. This over here,
Yes.
this is the effect of pressure
Mm.
on equilibrium. When we talk about effect of pressure on rate of reaction, so I will just write it down for you as well, so you can even learn it. Effect of, okay, effect of temperature. I will write it down for all of them. Effect of temperature on rate of reaction. So temperature, remember this. If you increase the temperature, the rate of reaction also increases. If you decrease the temperature, the rate of reaction will also decrease. And the same is true for pressure, right?
Yeah.
Effect of pressure on rate of reaction. So if you increase the pressure, the rate of reaction increases, meaning this reaction is going to be faster. If you decrease the pressure, the rate of reaction. And finally, catalyst. So catalyst is going to, if you talk about it, catalyst will increase the speed of reaction, but it has no effect on equilibrium. Equilibrium it has no effect on, but it will make the reaction faster. It can make the reaction faster, but it has no effect on equilibrium, right? So all you have to remember is this, what I have written down for you. What is the effect of temperature on rate of reaction? Effect of pressure on rate of reaction. Then equilibrium. So you have to remember, when temperature increases, we go to endothermic. Temperature decreases, we go to exothermic. Similarly, if we increase the pressure, less molecules, decrease the pressure, more molecules. And catalyst has no effect on equilibrium. So this is, if you remember this much, you will be able to figure out most of the questions just by remembering this much. Give me a second. Let me open up another question to
So, Miss,
practice for us. Hold on.
I have to
Yeah,
memorize
Dani?
first. Do I have to memorize
Yes.
first, then
Yes. If you memorize it, it will
answer?
make it much easier for you.
Uh, After like I memorize it, do I do more past papers or?
Yes. To try to definitely do more past paper practice. What you can do, Dani, is that I can send you questions if you want, and you can solve them and you can send them back to me after solving them. I can then check them for you and I can let you know whatever corrections are needed. Then I can go ahead and explain those to you.
Okay.
Okay. Now the question is saying again. So this is again about Haber process. I told you that there are few reversible reactions in your syllabus. So when you solve the past paper questions, you will see these few questions again and again. That's because there are only a few, 3, 4 reversible reactions in your syllabus. So you're not going to see a lot of different things in it. You're going to see pretty much all of the questions are going to look like they're the same. So, okay. First of all, state what is meant by this symbol. Do you know what is meant by this symbol?
It's the reversible arrow.
Yes, exactly. Exactly. So this is a reversible reaction. Correct. After that, they're saying that the forward reaction is exothermic. State the effect, if any, on the position of the equilibrium when the following changes are made. Explain your answer. So they are saying, first of all, what will happen? So we have to talk about temperature being reduced and pressure being reduced. This is our equation. And they have told us that the forward reaction is exothermic. So let's write that down. First thing we're going to write down is that what is the forward reaction? That's the first thing you will do. Forward reaction is exothermic. Now, the backward reaction is opposite. So what is the backward reaction?
Endothermic.
Correct. Now, when I will increase the temperature, where will the reaction go?
It will go to the. It will go to the endothermic side.
Correct. Correct. It will go to the endothermic side. And when I decrease the temperature, where will it go?
Exothermic side.
Exothermic side. Correct. Now over here, the question is about decreased temperature. So if I decrease the temperature, where should my reaction go? Should it go forward or should it go backward?
Decreased temperature. Decreased temperature is gonna go to the.
Yeah. If we decrease the temperature, should it go forward or should it go backwards?
it's gonna go to forward reaction.
Yes, correct. You are right because the forward reaction is the exothermic one. So it will go forward. You are completely correct. Now that it is going to go forward, so now that means forward is the right side. Okay? So that
Yes.
means our equilibrium is going to shift to the right. So when it will shift to the right, does that mean more product or less product?
Mm, less product.
More. Right means more. Right means more. Left means less. Right? Remember this. LL. Left is less. Right is more. Okay?
Okay.
Left
Yeah.
is less. Right is more. So
Okay.
I will get product, which means that what is my product? My product is NH3, right? Ammonia. So that means
So
I will get,
more NH3.
yes, exactly. That's what you're going to say. So that's the answer to part number one, right? They're saying state the effect, if any, on the position of the equilibrium. So they're saying temperature is reduced. So when we decrease the temperature, the reaction will shift to the exothermic side. That's exactly what you would say. You can use this entire thing to write down your answer. The reaction will shift to the exothermic side. So equilibrium will shift to the right. Hence, there will be more ammonia produced. Right? Making sense?
Yes. Yes.
Next, they're saying pressure is reduced. So again, we are talking about pressure being reduced. So let's take a look. What do we remember about pressure? If I increase the pressure, where does the reaction go? What side does it go to?
It goes to the. It goes to the left side.
Uh,
No wait. No wait. To the less molecules, which is the right
yes.
side.
Yes, we will go to the side with less molecules. And when I will decrease the pressure, it will go to the side with,
More molecules.
correct. So how many on the left side and how many on the right side?
Left side is 4, and
Yes,
right side is 2. So since
right. So
is the pressure is reduced,
yes,
we will go to the we'll go to the we will shift to the left side.
correct. And what will
So
happen to the product?
there will be more ammonia produced.
1 second. It will shift to left. Left is LL. Left is less.
Less molecules, so less ammonia
Less,
produced.
exactly, less ammonia produced. And that's your answer.
It's kind of hard, miss, like because it's
Yeah,
kind of confusing.
yes, it is. It's a bit complicated. But like I said, see, we will do a few more questions. I'll give you questions to practice. You'll see the questions are majority the same. So once you figure out how to do the question, you will see that they are just repeating. So
Mm.
once you figure it out, once you remember all of the information, the main trick is remembering because it's a lot to remember. I agree. So once you remember all of it, then you will see that the questions are the same. They're not really changing. They're not giving anything new. They're giving the same thing again and again. Okay, hold on. Let me open up another question for you. Okay, so this is a question again about, see, the type of reaction is the same. I told you they give same reactions again and again in all the questions. You won't see a lot of difference. So this is a question related to sulfur again. So describe two features of an equilibrium. So what are the features we discussed about equilibrium?
The rate of forward is equal to the rate of the backward.
Yes, correct.
and the concentration of reactant and product remains constant.
Correct. Now state the effect, if any, on the position of the equilibrium when the following changes are made. Temperature is increased. So let's take a look. What have they told us? They told us about, okay, they have told us the forward reaction is exothermic. So let's write that down. Forward reaction is exothermic. And our question in the exam is about what? They are asking us about what will happen if we increase the temperature. Okay, so let's go ahead and take a look. Let's go ahead and discuss what will happen if we increase the temperature. So when we increase the temperature, where does the reaction go? What have we studied?
It's gonna go to the endothermic side.
Right. So if we increase the temperature, it goes to the endothermic side. You're completely correct.
That means the reaction will absorb heat.
Yes, exactly. To endothermic side. Correct. Now, so if the forward reaction is exothermic, what do you think the backward reaction is?
Endo.
If the yes. So forward reaction is exothermic. That means that the backwards reaction is endothermic. Now, if I increase the temperature, you told me that the reaction goes to the endothermic side. So is that forward or backwards?
Backwards.
Right. So backwards is left, right? Backwards is the left side.
So less product.
Yes. Equilibrium will go to left and we know LL. Left is less. So
Yes.
we'll get less product. And how will you explain it in the exam? You will say that when the
Less
temperature, yeah,
less sulfuric dioxide produced.
yes, sulfur trioxide will be produced. So you
Yes.
will say that the forward reaction is exothermic and the backward reaction is endothermic. When you increase the temperature, the reaction goes to the endothermic side. So the equilibrium will shift to the left and we get less product. That's it. Same thing that you're figuring out, you will write down the same thing as your answer. Next, they're saying pressure is increased. So when pressure is increased, what will happen? So when I increase the pressure, where does the equilibrium go? To which side?
It will go to the side that has less molecules.
Correct. It will go to the side with less molecules. What does left side has and what does right side has? How many
So
molecules left?
the right has
Yeah.
2 and the left
Yes.
has 3. So it's gonna go to the
Correct.
right.
Right. Equilibrium will go to the right side. So am I going to get more product or less product?
Mm, more product.
What left is less. So right is the opposite, right? Left
Yeah,
is less. So remember,
more.
right is the opposite. So I will get more product. So sulfur
Yes.
trioxide I will get more SO3. So that's what you write down as your answer. That when pressure is increased, the equilibrium shifts to the side with less number of molecules. So equilibrium will go to the right side. So more product and more SO3 will be made. That's it. That's your answer. Okay, let's go ahead and open up another question. Hold on.
I feel like all the questions are the same.
That's exactly what I was telling you. That all the questions on this topic are pretty much the same. There's not a lot
And
of
they're asking about the same thing. Like
yes,
they're asking about.
exactly. Yeah, pressure increased, pressure decreased, temperature increased, temperature. They're asking you the same thing. That's exactly what I told you. So if you remember, just if you remember, learn
Yes.
the effect of pressure, temperature, and catalyst, you can solve most of the questions completely easy because they're all pretty much the same. That's exactly what I was telling you, that it's complicated because you have to learn it. But once you've learned it, then they all are pretty much the same. There's not a lot of difference in them. Now here,
Yeah,
take
I
a
don't
look at this question.
I don't know how the teacher's gonna find questions about this because they're gonna all be the
Yeah,
same.
now that is something different. How the teacher gives the question, that's up to the teacher. Okay, take a look.
Okay.
This question is about compounds of phosphorus. Gaseous phosphorus chloride decomposes into gaseous phosphorus trichloride and gaseous chlorine. Okay. When three gases are present in a closed container, the system reaches equilibrium.
Equilibrium.
Complete the
Yes.
table only using the word increase.
Decrease or no change.
Yes, exactly. So, what are we going to go ahead and see? Let's discuss. Okay, first thing is first, we have to talk about rate of reaction, not equilibrium, rate of reaction. So right now, I wrote down everything for you. So I had told you what is the effect on the rate of reaction. So let's discuss that. So if I will increase the temperature, what will happen to the rate of reaction, the speed of reaction?
The rate of reaction increase.
Yes, correct. And if I decrease, what will happen?
It would decrease the rate of reaction.
Correct. Correct. Very, very good. And what about pressure? If I increase the pressure, what will happen to the rate of reaction?
Rate of reaction increase, and when we decrease
Yes,
pressure, it will decrease the rate of reaction.
correct. Good job. Rate of reaction will increase. And if I decrease pressure, the rate of reaction decreases. Finally, what is the effect of catalyst? Catalyst will?
Catalyst will the catalyst only affects the speed of the rate of reaction.
Yes, it will increase the rate of reaction. You are correct.
Yes.
So, okay, if I increase the temperature, what will happen on the rate of reaction? What should I write down? You can look from our table over here. When I increase the temperature, what happens to the rate of reaction?
Increase.
So I will write down increase. Okay, decreasing pressure. So when I decrease the pressure, what happens to rate of reaction?
Decrease.
Correct. And when I add a catalyst, what happens to the rate of reaction?
Decrease.
If I add a catalyst, what happens to the...
Increase.
Correct. Good.
Okay.
Now we have to take a look at equilibrium. So we don't have to worry about pressure because they've already, sorry, temperature, because they've already told us the answer. They're asking us about pressure. Let's figure it out. Okay. So they're decreasing the pressure. So if I increase the pressure, so they're saying what will happen if we decrease the pressure. So if we decrease the pressure, where does the equilibrium go?
Decrease the pressure. It's gonna go to the side that has greater molecules. More
Correct.
molecules.
How many on the left side and how many on the right side?
On the left side is one. Left side is one. Right side is two.
Correct. So where is my equilibrium going to go when I decrease the pressure? Will it go towards left or towards right?
To the right.
Correct. So what's going to happen to my product?
More product is gonna
Yes.
use.
Yes, exactly. More product. So I will over here write down that my product is going to increase. Right? That's it. Now,
Okay,
let
so
me
the
put
topic
something
is
interesting
easy.
in front of you. Let me
It's not
put,
bad. It's not bad.
yes, it's not bad. It's not bad once you learn it. But now let me ask you something slightly tricky, okay? The table
Okay.
shows that when the temperature increases, the equilibrium yields of product, these are your products, right? PCl3 and chlorine. So they're
Yes.
saying the equilibrium yields of PCl3 and Cl2 increase. State what conclusion can be made from this. Basically, what they're asking you is this, that normally what they do is that they tell you that the forward reaction is, for example, exothermic, or the forward reaction is endothermic. They tell you that, right? And then they
Yes.
ask you, what will happen if I increase the temperature or decrease the temperature? This time, they have done the opposite. They have told you the answer for temperature, and they're asking you, can you tell us, is the reaction exothermic or endothermic? So we will have to do backwards thinking, okay? Okay. So let's take a look. What are they saying? In the exam, they have told, we did not figure it out. They have told us that if we increase the temperature, the product is increasing. Okay, that's what they told us in the exam. Here in the table, it says
Yes.
product is increasing. Okay. So if I increase the temperature, to which side does the reaction go? Does it go, when I increase the temperature, to which side does the reaction go?
Endothermic?
Correct. It goes to the endothermic side. So, okay. When the okay, so the reaction goes to the endothermic side. Now, over here in the question, they're saying product is increasing.
Yes.
What side means more product? Does the right side mean more product or the left side mean more product? Does the right side
More
mean more
product.
product or right side or left side? Which side means
Right.
more product? Right side, right? So that means when
Yes.
I am increasing the temperature, so when I am increasing my temperature, they told me that the product is increasing, right? That's what they told me.
Yes.
They said, they told me. I didn't have to figure it out. They told me that your product is increasing. So I
Yes.
know my product is increasing. And you and I know that the product will increase on the right side. The product increases on the right side. So that means my reaction must be going to the right. Yeah, that's what it means. That's why I'm getting more product. My equilibrium is shifting to right. Now, when I increase the temperature, the reaction goes to the endothermic side. So what does that mean? That means that the right side must be the endothermic one, right?
Yes.
Because when I'm increasing the product, that means I'm going to the right side. Equilibrium is shifting to right. And we also know that when we increase the temperature, the reaction should go to the endothermic side. So when I'm increasing the temperature, the reaction is going to the right. That means right is endothermic. So what does that mean? Right side is the forward reaction. So that
Yes.
means forward reaction is, so it means forward reaction is endothermic, and that's the answer. This was the slightly tricky portion where normally they would tell you the statement, they would tell you if the forward reaction is endothermic or exothermic, and then they ask you, okay, what will happen if I change the temperature? This time they made you think backwards. They said, we will give you the answer and you figure out the question. That's basically what they did, right? So they told you the answer. Okay, if I increase the temperature, the product will increase. So we had to think
Mm.
backwards and figure out, okay, so
Yes.
what is the reaction? Is it endothermic reaction or exothermic reaction? So backwards thinking, this is where we had to do backwards thinking. So if I
Yes.
increase the temperature, what does that mean? Product is, must be, it's increasing. They told us, we didn't have to figure it out. So we
Yes.
know that more product is right side. So equilibrium is going to the right. So we know that. Now, we know that when we increase the temperature, we always go to the endothermic side. So that means the right side must be the endothermic one. So forward reaction
Yes.
is endothermic, and that's your answer. So
So
that
we
was, yeah,
so we can we just write can we write, like, since it's a one mark question, can we just write
yeah,
it
yeah,
as
yes,
endo?
yes, exactly. Forward reaction is endothermic, just one line. That's it. You don't have to write down the entire explanation. The entire explanation is just for you and me. That's it. It's for us to discuss and for us to understand. That's it. In the exam, you don't have to write down any of this long explanation. You can just write down one line. Forward reaction is endothermic. That's it. Okay, let's open up another question. Give me a second. Okay, this is another question I'm just showing you. This question is the compounds that you're going to see, they might be a bit new for you, but don't get confused because that's just from the topic of organic chemistry. Okay. So these compounds are compounds you will inshallah study when we do organic chemistry, but the topic of equilibrium you and I can solve. Ethanoic acid is manufactured by the reaction of methanol with carbon dioxide. An equilibrium mixture is produced. State two characteristics of an equilibrium.
Um, the rate of the forward reaction is equal to the rate of the backward reaction,
Correct.
and
Correct.
the concentration of reactant and product remains the same.
Correct. Will be constant. Okay. Now they're saying the purpose. This is okay. Again, don't get confused by the question. They're asking you the same thing that we were discussing in all the questions, but just in a different way. Okay. The purpose of the industrial process is to produce a high yield of ethanoic acid at a high rate of reaction. So they want a lot of product and they also want the rate of reaction to be high. They want a lot of product and they want it quickly. Okay. The
Yes.
manufacture is carried out at a temperature of 300 degrees centigrade. Okay. The
Yes.
forward reaction is exothermic. Use this information to state why the manufacture is not carried out at temperature below 300 degrees centigrade. Let's discuss. Okay. So below 300 degrees centigrade means that I'm decreasing the temperature, right?
Yes.
Okay. If I decrease the temperature, what will happen to the rate of reaction? What will happen to the speed of reaction? Reaction will be faster or slower?
Slower.
Correct. It will decrease. Good job. Okay. Now let's talk about the equilibrium. We know that the forward reaction is exothermic, right?
Yes.
So when I decrease the temperature, where does the equilibrium shift?
To the exothermic side.
Yes, correct. When I decrease the temperature, the reaction shifts to the exothermic side. So which is the exothermic side, the forward or the backwards?
Forward.
Forward. That means my reaction will go forward. So forward is the right side, correct?
Yes. Yes.
So does that mean I get more product or less product?
More product.
Correct. Now, they're actually asking me this. They're saying, why can I not do the reaction below 300 degrees centigrade, right? Why can't we do the reaction below 300 degrees centigrade? If we
Because
look at the product, it's actually a
yes.
good thing, right? Because
Yes.
when I'm decreasing the temperature, I'm getting more product, right? That's
Yes.
actually a good
Yes.
thing. So why is
Yes.
it that I don't want to do the reaction below 300? Because of this.
The
Because
rate of
even though
reaction decrease.
rate of reaction is decreasing, so they want a lot of product, but they also want a high rate of reaction. So below 300, yes, I will get more product, but my rate reaction will become slow. So the answer will be because the rate of reaction
Yes.
Reaction will become lesser because the rate of reaction will decrease, right?
Yes.
Okay,
Yes.
let's take a look at the next one. Next one, they're saying above 300 degrees. So above 300 degrees means that I am increasing the temperature, right? I'm going above 300. I'm increasing the temperature. So when we increase the temperature, what happens to rate of reaction?
It goes to the endothermic side. The rate of reaction increase.
Correct. Correct. And when I increase the temperature, it goes to the endothermic side. Correct.
Yes. So it
So,
goes to the left side, which is the less
yes.
product side.
Yes.
You're gonna get less product.
Yes. So backward reaction is endothermic. So the equilibrium will shift
To the
to
left side.
left and less product is made. So the good thing about going above 300 is that my rate of reaction will be high. That's the good thing about it. My
Yes.
reaction will be faster. But what's the bad thing about it? I will get less product. So that's the
Yes.
reason I don't want to do it above 300, because above 300 I will get less product. And that's your answer. Don't have to write in all this explanation. It's a 2-mark question, one statement for each. Why are we not doing below 300? Because the rate of reaction will be too slow.
Decrease.
Why are we not doing above 300? Because
Because the rate of reaction increase.
no. Why are we not doing? They're asking you, why are we not doing above 300? The reason we're not doing above 300 is because we're getting less product,
Oh, yes.
right? We were getting less product. So that's why. Rate of reaction is increased. It's good. But they're saying, why would I not want to go above
So
300,
we
right?
can mention both. We can mention that the rate of reaction increase, hence we will get less product.
Okay. When you say hence, so hence means that hence is like because of. So it's like you're saying rate of reaction will increase, and that is why I will get less product. That's not true. Okay. Because
Okay.
rate of reaction does not affect the equilibrium. That's the other thing, endothermic, exothermic. So over here, just write down one straight line. It's a 2-mark question, one line. Because
Yes.
I will get less, you can even use the term from the question. I will get less yield of ethanoic acid. I will get less product, less yield of ethanoic acid. And why
Okay.
do I not want to go below 300? Because the rate of reaction is low. That's it. Okay. Okay, Danya, we'll go ahead and, okay, actually, let's just do this. Now they're saying complete the table using only the words increase, decrease, or no change. Okay. When I add a catalyst, what happens to the rate of reaction?
Increase.
What does a catalyst do to the rate of reaction? Increase.
It
Correct.
it
It will increase the
decreases
rate
the
of
speed.
reaction.
It decreases the speed.
No, a catalyst. If I add a catalyst makes the reaction faster, right?
Yes.
Yes. So it will increase the rate of reaction. Okay.
Yes.
Next, they're saying pressure. Okay. What is the effect of pressure on the rate of reaction? If I decrease the pressure, what happens to the speed of reaction, the rate of reaction?
It's gonna decrease. It's gonna decrease.
Yes, correct. So I'm going to write down decrease. Next, they're
Yes.
asking us effect on the product. So to see the effect on the product, I will actually have to look at my equation. So tell me
So it's
over
gonna
here,
increase, right?
hold on. If I decrease the pressure,
We'll get more molecules.
we will go to the side with more molecules. How many molecules on the left side and how many on the right side?
We have 2 on the left side and 1 in the right side.
Right. So where is my equilibrium going to go? Is it going to go to left or right?
Left.
Left. So does that mean I get more product or less product?
Less product.
Less product. So my answer over here is going to be that my product is going to decrease. That's it. Solved. Okay, all clear. I hope no confusion.
No confusion.
Okay, all right. Okay, Dania, I will go ahead and stop it over here. And what I will